I have come up with another problem for IIT advanced level. और मैंने पहले भी कुछ प्रॉब्लम सॉल्व करके दिए हैं आपको, वो स्प्रिंग पर और भी और प्रॉब्लम्स जो मैंने आपको सॉल्व करके दिए हैं इन द शॉर्टेस्ट एंड स्मार्ट वे. आपके बाद जो मैंने प्रॉब्लम लाया है वो ये है कि चार्ज पार्टिकल्स मूविंग इन सर्कुलर ऑर्बिट मे बी एक्सेलरेटेड बाय द EMF व्हिच अराइजेस व्हेन द मैग्नेटिक फ्लक्स एनक्लोज्ड बाय द ऑर्बिट चेंजेस. Show that if the radius of the orbit remains unchanged, the magnetic flux density at the orbit must be 1/2 of the average flux density. Flux density means magnetic field within the orbit. Take the magnetic field as perpendicular to the plane of the orbit. Question कुछ ऐसे हैं कि we need to accelerate charged particles in the varying magnetic field. As you know, the varying magnetic field or varying magnetic flux creates induced EMF. Before that, before it creates induced EMF, it produces circular electric field. और circular electric field को integrate करने से ही आपको induced EMF मिलता है. तो question is something like this. You see, if we have a magnetic field like this, we have a magnetic field like this. Perpendicular to the plane of the board. This is the magnetic field, right? And this magnetic field changes in time. It is a time varying magnetic field. When it is a time varying magnetic field, it will create electric field in circular paths around the center. This will create electric field in this direction. Tangential electric field to the circle. And if you integrate this electric field over this path, means E into 2 pi r, that is the induced EMF. So as you already know, that change in magnetic flux gives rise to induced EMF. But the change in magnetic flux, basically, it gives rise to a circular electric field. And when you integrate the circular electric field over the path, it gives you induced EMF. The equation is like this. Induced EMF is equal to, as you know, integration of E dot dl, integration of electric field over path, and that is equal to minus d pi b by dt. This is the rule. Generally, what we do, we say induced EMF is equal to minus d phi by dt. That is what everybody knows. But this is also very important. The changing magnetic flux basically produce electric field in circular paths, and that is just equal to the induced EMF. So what we do, the magnetic field which is perpendicular to the plane of the board, and the electric field is produced like this. We keep charge here, charge Q. Now this charge Q is, when this magnetic field changes, when this flux changes, this gives rise to the electric field in circular paths, and now this charge is in the electric field, and it will create a tangential force on this charge, and the tangential force will accelerate the charge. When this charge gets accelerated, its speed increases. When its speed increases, it will become a bigger and bigger circle. The charge will now move in a bigger and bigger circle, which we don't want. We want that this circular orbit should remain fixed. So what should be the what should we do, or what should be the mechanism or the configuration of this magnetic field so that the orbit of the circle remains fixed? That's what we what's the problem is. The orbit should remain fixed, and the magnetic field which change in time also should change in space. It should change with position also. That means magnetic field should change with position when we go away from the center. So the magnetic field on the periphery, on the periphery of the circle, what should be its relationship to the average magnetic field inside the circle? That is the question. And the question says we have to prove, if in order to keep the orbit constant, हमें prove करना होगा कि magnetic field जो periphery पर है, that should be 1/2 of the average magnetic field inside the circle. That is what we have to prove in order to keep the orbit constant. Okay, but basically this concept is used to accelerate the charged particles. So what should we do? First of all, how can we find the electric field on the periphery? The electric field on the periphery can be found like this. Integration of E dot dl is equal to that is equal to minus d phi b by dt. Okay, so here you are integrating the electric field over this path. So integration of electric field over this path is E into 2 pi r, because angle between the path length and electric field is 0. So the dot will go to the cos 0, that is 1. So it is E dl. That is E will come out, and integration of dl is L, and this L is 2 pi r. Again, I will repeat. So dot will go because the angle between the path length and the electric field is 0, and cos 0 is 1, and it will become E dl cos 0, that is E dl. So E will come out because E is constant on the circle in magnitude. Electric field का जो magnitude है, that is constant on the circle, and L, total L will be the 2 pi r, is equal to how much? Minus d by dt into what is flux? That is pi r square b bar. Why b bar? B bar is the average magnetic field from here to the onto the periphery. Average magnetic field in terms of space average, not time average. The magnetic field anyway changes with time, but it has also to change with space. If it changes with space, only then we can find average from center to this to the periphery, if center is O. So the magnetic field which is inside the circle should be changing in both. It should change with this time to produce the induced EMF or the circular electric field, and also it should change with position. So magnetic field should change when we go away. Should it decrease or increase, that will we will find through the equations. The magnetic field at the periphery, let me suppose that is B. Okay, so what we do is it is electric field into 2 pi r is equal to pi r square is constant if r has to remain constant into dB by dt average. Okay, now let me go to the next page. Okay, E into 2 pi r is equal to minus pi r square dB by dt. It is average magnetic field, space average. Again, I will make the diagram here. This is the magnetic field. And this is the charge moves in a circle here. This is the radius r. Magnetic field here is B, and at this center is C center, and here it is the electric field, tangential electric field on the circle, and this electric field is produced by the changing magnetic field inside the circle. Now this pi goes, r also goes. What is the electric field? That is minus r by 2 dB average by dt. This is the electric field which is produced on this periphery due to the changing magnetic flux here inside. So of course magnitude electric field is equal to r by 2 dB by dt. Magnitude के हिसाब से ये. This is the magnitude of the electric field. But when the charge is here and now it is in the electric field, charge is here, now it is in the electric field. So can you tell me what is the force on the charge? The force on the charge will be Q into electric field. So the force on the charge is equal to QE. That is Q R by 2 dB by dt. This is the force on the charge. This force on this charge, tangential force. And due to this force, it will get accelerated. So what is this acceleration? What should be the acceleration of the charge? The acceleration is F by m, as we all know, that is Q R by 2m dB by dt. Right? So the charge gets accelerated. This charge gets accelerated. Its speed increases. So with the increase in speed, now there's a possibility that the charge may fly away and it will begin to move in a bigger circle, right? But now we have to keep R constant. For that, that's why we say that there must be a space variation of the magnetic field. And the question is, what should be this magnetic field? How this magnetic field should be related to the inside average magnetic field? So we have to prove this magnetic field should be B average by 2. That's what we have to prove. Only then the orbit of the circle will remain constant. So what should we do here? Okay. This is the acceleration. Keep the acceleration with you, right? Remember this. Now, as you know, when the charge moves in a circle, there must be a centripetal force to keep it moving in a circle. Who gives the centripetal force? The centripetal force is provided by this magnetic field, which is inside. This magnetic field is inside. The magnetic field inside and velocity has this direction. This is the direction of the velocity. This is the direction of the velocity. This is the magnetic field inside magnetic field. If you go V cross B, the force is towards the center. The force is, the magnetic field is inside, the velocity is like this tangential, and V cross B is like this, that is toward the center. So it is the magnetic force, the magnetic field which is on the periphery, that produces the centripetal force which keeps the charge moving in a circle. How much is that magnetic force? That magnetic force is which gives the centripetal force mv squared by r. This is the centripetal force, and it is being provided by the magnetic force, that's qvb. Why? Because velocity is like this tangentially, and magnetic field is inwards, and the angle between V and B is 90. That's why QV cross B will become QVB, because V and B are perpendicular, and QVB will be the magnetic force toward the center. Okay. Now from here, what we do? One V will cancel, and V will be equal to QB R divided by M from this equation. And also, if we differentiate this, that will be dV by dt. That will be Q is the same, R is the same because it has to remain constant, M is the same as mass, and we will differentiation will be B. But it is the differentiation of the magnetic field on the periphery of the circle, right? So again, it is acceleration. That is QR by M dB by dt, right? Now we have to equate equation 1 and equation 2, and let us see what we get. Is the acceleration, that's QR by M dB by dt, and it is also the acceleration QR by 2M dB bar by dt. If we equate the two accelerations, what we are going to get? That is equating first and second, that is QR by 2M dB bar by dt is equal to QR by M dB by dt. This is the magnetic field on the periphery of the circle, and this is the average magnetic field inside the circle, right? From here, what we get? From here, what we get is QR cancels, M cancels, and here we get dB bar by dt 1 by 2 is equal to dB by dt, right? Now, it is d by dt. If we write it like this, it is d bar, average magnetic field inside the circle, divided by 2 is equal to d by dt b, magnetic field on the periphery. Okay. Now it is, if you integrate both sides from here and here, we'll get the differential integral cancelled. We get b bar by 2 is equal to b. That's it. So if the magnetic field on the periphery is equal to half the average magnetic field inside the circle, then the orbit will remain the same. I mean, the charge will move in a single orbit. It will not go away, or it will not go come closer to the center. It will keep the orbit. So this is how we accelerate the charged particle in a single circle. Now, the point is, number one question that you can ask to your teachers, and you can just write in the comment section, how such a field can be realized in practice. Practically, how such a field can be realized. Practically, how such field is realized. ये फील्ड, इस किस्म का फील्ड कैसे हम बना सकते हैं, कैसे हम इसको इंप्लीमेंट कर सकते हैं, इस फील्ड पैटर्न को. एक तो फील्ड should change with the time. Also, it should change with space, so that you can accelerate the charged particle in a single orbit. It should go on accelerating. It should speed up, and finally, the charged particles, when they speed up, they are used in nuclear transmutations. They can be used in splitting the nuclei. They can be used in what you call as in nuclear experimentation, or in laboratories, splitting the nuclei, releasing the energy. The charged particles, it has always been a problem with the scientists to accelerate the charged particles, and they have designed accelerators. They have designed accelerators which are very longer in size. Even they extend to the kilometers, and they accelerate. How they accelerate the charged particles? Through potential differences. They produce the potential difference, accelerate the charge, and again produce the potential difference, accelerate the charge, and they accelerate the charge over kilometers, and only then they can get the energy in million electron volts or giga electron volts, so that they can be useful in splitting the heavy nuclei. But here, first of all, my question is practically how such field is realized in real time. Next question जो मेरा है, which you can talk to your teachers, which you can discuss with your teachers. These are very good, this is good physics that we are discussing here, and come with this answer. Which device has been invented? Which device has been invented on this principle? Which device is invented? Which device is invented based on this principle? इस प्रिंसिपल के बेस पर कौन सा इंस्ट्रूमेंट साइंटिस्ट ने डिजाइन किया है? Okay, if you allow me a few more minutes, I will again explain you. This is the magnetic field. Suppose if it is this is the magnetic field, which is the function of time. It will produce electric field around it. If this is the magnetic field, the marker gives the direction of the magnetic field. This is the electric field around this, around the change in magnetic field. This is the electric field, and there's a charge this, and it gets accelerated because of this electric field. जो इस सर्कल के अंदर मैग्नेटिक फील्ड है, उसका एवरेज जो है, और जो सरफेस पर जो पेरिफेरी पर मैग्नेटिक फील्ड, उसमें रिलेशन होना चाहिए. जो पेरिफेरी पर मैग्नेटिक फील्ड है, that should be half the average magnetic field inside. So magnetic field should change both with time, and it should change with position, with space. Thank you. This is the end of the lecture.